Now we're going to take a look at an important and very common example. This is called the geometric series. And what we have is a plus a times r plus a times r squared plus a times r cubed and so on. So our summation notation is a times r to the n minus 1. Notice we've got this power n minus 1 since r starts at 1 and our first term here doesn't have any r terms in it. So we would like to try to find the nth partial sum to see if we can determine under what circumstances we can find the sum of this series. So the nth partial sum is going to be a plus ar plus ar squared plus dot 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 plus ar to the n minus 1. And what we're going to do is we're going to multiply both sides of this equation by r. And what you'll notice is I wrote it so that it was offset so that my like terms line up. There are n terms in the top one and there are n terms in the bottom one. But we're kind of, by multiplying by r, all of those powers have now increased by 1. So what we're going to do is we are going to add these two rows together, actually subtract these two rows, so that we have s sub n minus r times s sub n is equal to, if we subtract, all of these middle terms here will cancel out, and we have a minus a r to the n. Remember, our goal is to find a form for s sub n. So factoring out s sub n, we have this on the left-hand side. It's sometimes convenient to factor out a on the right-hand side, so 1 minus r to the n here. Dividing both sides by 1 minus r gives us s sub n equals a times 1 minus r to the n divided by 1 minus r. Okay, so that's our nth term, which is way nicer to work with than this sum of n terms. So now the question is, what can we say about the limit as n approaches infinity of this? Notice this limit is dependent on n, and the only n we have is in the exponent here. So we'll just use some of our limit laws to simplify this, which gives us the limit of, let's see, we can split that back up or distribute that a back in, and we have the limit as n approaches infinity of a over 1 minus r minus the limit as n approaches infinity of a times r to the n over 1 minus r. So here, the first part of this limit is just a minus a over 1 minus r. Since there aren't any n's in here, this is just a constant. For the second part of this limit, it's going to depend on what r is. If r is greater than 1, this limit diverges. If r is equal to 1, this limit diverges. If r is less than or equal to -1, this limit diverges. But if r is between -1 and 1, then this limit goes to 0. So our limit is a over 1 minus r when r is between -1 and 1, not equal to. And we can remember that from the last section where we talked a little bit about r to the n, what conditions, what will allow this to be a convergent limit. So kind of as a summary, the geometric series where we have a times r is sometimes called the common ratio. The sum of the a times r to the n minus 1, it's convergent if the absolute value of r is smaller than 1, that is, r is between -1 and 1, and its sum is a divided by r minus 1. This is an important result. I'm going to highlight it. If r is greater than or equal to 1, or less than or equal to -1, the series is divergent.